Good day, everyone. Today we're gonna look at the parallel lines. But anyway, I should say welcome back. Today we're just gonna look at the overview of the parallel line. That is the angles that are found between the parallel lines. So what I have here is just a drawing for those type of angles that are found between the parallel line. For the parallel lines, first of all, what we have is just they usually say parallel lines, the lines that are going in the same direction, but they will never meet. So we have also what is called the transverse line. The transverse line here, transverse line, TL for transverse line. The transverse line here is a line that helps us to cut those parallel lines and then produce some of the angles. And then when it cuts those parallel lines, we have what we have some of the shapes there. That is a Z shape. Here it produces a Z shape, and when it produces that Z shape, it produces some of the angles between those parallel lines, and then those angles are what is called the alternate angles. Once it has a Z shape like this, and then it's a parallel line parallel to this one, and then once it has a Z shape, that is a Z shape, you must know that it is a what? It is an alternate angle. Alternate angles once it has a Z shape. So once we have those Z shape between the parallel lines, since the transverse line cuts those parallel lines, once it forms a Z shape, you must know that it is an alternate angle. And one more interesting thing about the alternate angles is that they are equal. So alternate angles, they are equal. So now what we have between the parallel lines is just that we have one of the angles that are found between the parallel line, that is alternate angles. And now let's look at the one of the other angles that are found between the parallel lines. And now we have here also a transverse line that cuts the parallel lines. Here are the parallel lines, and then the transverse line, it cuts those parallel lines. And then what we have now here, it's just that it's not a Z shape, but it's an F shape. What is more special about an F shape, and what can we relate to when we have an F shape instead of a Z shape? And now we have an F shape here. These are the parallel lines, and then we formed an F shape. Once you see something like an F between the parallel lines, here we have to recall about something that is called the corresponding angles. So here, these are the corresponding angles. Corresponding angle. Corresponding angles. You can also use this sign for angles. Also, you can use other signs for angles, but I use this one for now. They say Euclidean geometry is nice with the signs, so we use signs here in Euclidean geometry. You will see as I go through the other videos. Since there is an upcoming video, that is why I'm doing this video as an overview for the upcoming video. That is it is more tricky, so I need to all those things so that you can recall when you are watching the upcoming video. So now the corresponding angles here. So here the corresponding angles here, you can see now here we have an F shape. Here it is our F shape. It produces our F shape here. Here you see. So now on those corners of the F shape, what you can see there is just that there is an angle here, and also there is an angle here. So what is more special about the corresponding angles is just that those angles that are produced by the F shape here, they are equal also. So the corresponding angles produces the angles that are equal to each other. So that's it for the corresponding angles. It forms a F shape. The corresponding angles, they are equal, provided that a line that are parallel to each other, and then the transverse line cuts and then produce an F shape. That's it for the corresponding angles. Now we're gonna go over for co-interior angles, that is the parallel lines and then the transverse line that cuts those parallel lines. It forms a C shape there. So now the C shape is something like this. Here it has corners like a C, you see. So now it's a C shape here for the corresponding angles. And something special about the corresponding no, not the corresponding angles, but the co-interior angle. So it's a co-interior angles here. The co-interior angles here. So there's something special about co-interior angles. It's just that those angles that are produced between those parallel lines, they are supplementary to each other. So what do I mean by supplementary to each other? It's just that this angle and this angle, when they are adding to each other, they probably produce 180. So they add up to 180. So that's why we say they are supplementary to each other. They are not equal, but they are supplementary, meaning they add up to 180. That's why we have a C shape there. So that's it for the parallel lines. I just wanted to give you that I should mention also that they add up to 180 here, 180 degrees. So that's it for the corresponding angles, alternate angles, co-interior angles. Something that you should know or look at it is just that for alternate angles, you have to look for a Z shape, and once you found that Z shape, you should know that they are equal to each other. And then for your corresponding angles, you have to look for an F shape. Once you find that F shape, you should know that they are equal to each other. And then for the co-interior angles, you have to look for a C shape. Once you find that C shape, you should know that they are adding up to 180. So that's it for those parallel lines. One thing I should do for you is proving proportionality theorem. So now we just gonna look at the ratio and proportion, since we're gonna prove the proportionality theorem. So I just want to make sure that you understand the concept of proportion first, and then we go and dive deep in proving the proportionality. So now the ratio and proportion, I want you to understand it first by a good example. I'm just gonna use this example of saying we got these four lines here, that is line A, line B, line C, and line D. So for line A here, I'm just gonna give it a 2 centimeter, 2 units, and then for line B, I'm just gonna give it 6 units, and then for line C, I'm just gonna give it a 1 unit, and then for line D, I'm just gonna give it a 3 units. Okay, now let's take a ratio of line A is to line B, and then we take a ratio of line C is to line D. And then for a ratio of line A is to line B, we simply say here. So now for the ratio of line A is to line B, we say line A here is to line B. And then we know here that line A, we can represent it with the 2 units. We say now 2 units here is to line B, we can represent it with the 6 units. So here it's a 6 units, 6 units. And then we can go further and simplify this one and say 2 can go to 2, and then 2 also can go to 6. Once 2 goes to 2, we are left with the 1, and then once a 2 goes to 6, we are left with 3. So the ratio of line A is to line B is simply equals to 1 is to 3. And then for the ratio of line C is to line D, we can go further and have that ratio and say line C here is to line D, and then when we represent the line C here with its unit, we get 1 unit, and then we say it's 2, and then the line D we can represent with a 3 here, and then we can simply see now here that the ratio of line A is to line B is in the same proportion with the ratio of line C is to line D. So the ratio of lines A and line B is equals to the ratio of line C is to line D. And now we can say here that line A is to line B is in the same proportion with the line C is to line D. So line A and line B is in the same proportion with the line C is to line D, is in same proportion with the line D and line C and line D here. I hope you all see that. So now when we represent the same proportion here, we can just simply say line A here over line B is equals to line C over line D. And then we know that these they have the proportion that is 1 over 3. They all have that proportion that is 1 over 3. So that's it for the proportion, the overview of the proportion. Now we're going to dive deeper to proving the proportionality. So yeah. Right, now we are looking at proving the proportionality theorem. So we are required here to prove AD over dB, which is equals to AE over EC. Okay, now let's look at what we are given here. So the given one, let's say given. So the given one here, we are given that we have a triangle ABC with a D that lies on AB, and then with the E that lies on AC, and then now we have a DE, a line DE that is parallel to line BC. That's it for the given one. So now we need to construct. What do we construct here? So for construction, we say here we draw the altitude. Ever since I've drawn the altitude, I will just write here we draw altitude. Draw altitude that is H and K in triangle that is triangle A D E, and then now we join the lines BE, also join line BE and DC. So that is the construction that I have. We draw the altitude H and K in triangle ADE and join the lines BE and DC. Okay, now since we have the altitude and the bases, what we can do now is just that we can find the area of each of the triangles that are found in triangle ABC. So for the areas, we can say here now area of triangle ADE that is area of triangle ADE. And then since this area has an altitude that is h, we can just look at the other triangle that has an altitude that is h. So I've done it over here. I did some of the sketch here that shows the triangle with an area with an altitude that is the same with the other triangle. So we have triangle BDE here with an altitude that is h, and then looking over here, we have a triangle ADE with an altitude that is h. So now we've seen that triangle BDE and triangle ADE, they share the same height, that is h, and then we can take the proportion of the area of triangle ADE with an area of triangle that is BDE. So looking at the area of triangle ADE, we can say half the base of ADE. Here ADE, the base here is AD. We say AD, and then for the height we have altitude that is h, and then we say over half the base of BDE. The base of BDE is BDE, and then we have a base that is BD, and then we say BD, and then we say the height of BDE is h, as an altitude that is h over there. And then we say here half times AD times h. We can see that we have a half here, we have a half here, we can easily cancel out them, and then we have a h here, we have a h, and then we can cancel them out, and we are left with the AD over BD here. And then we say our reasoning here over here now says they share the same height, or they have the same height, height or altitude. It's up to you if you want to say it like that. Say the same height or altitude. It's correct anyway. So for the area of triangle ADE over area of triangle BDE, we've got half that is AD times the altitude that is h over the half BD with an altitude that is h, and then now we are left with the AD. And then we take a look at the triangles that share the same height, that is k. Now looking over here, we have a triangle that is CED with an altitude that is k over there, and then we have the triangle that is triangle ADE, now AED, if you can say so. AED or ADE, it's kind of like the same thing. AED have an altitude that is h over there. So let's look at the triangle that is AED and the triangle that is CED. So taking the proportion of the area of triangle that is area of triangle AED over the area of a triangle CED, and then we say area of triangle AED here over here, the base of AED it's AE. Okay, let's first say half, and then the base of AED it's AE, and then for the altitude we have a k, and then we say over here it's a half, the area it's half base times height. I hope you all know that it's half here, and then for the base now it's CE over here, and then the height we said they share the same height, so it should be k over here. So now what you can do now is to cancel out, because half multiplies AE multiplies k over there. So since they multiply, we can cancel them out, and then over here we have a k, we can cancel them out, and then we are left with the AE over the CE over here. So now we say the same thing as we said over there. They share the same height, share the same altitude. Let me say so now, altitude, that is k here, let's mention it as a h. So now we find the areas of triangles that are there in triangle ABC, and then now what we didn't mention is that a triangle, area of a triangle, we can say here, but area of a triangle BDE, of a triangle BDE, the one that is found between the parallel lines over there. So we say area of triangle BDE is equals to the area over here of a triangle CED, because they share the same base and altitude between the parallel lines. So they share the same base, so they share here the same base, share same base and altitude between the parallel lines. We can also mention those parallel lines as BC, that is parallel to DE. So now we've got that, and now what we can say here now is just that since we were proving the proportionality, we can say now the area of triangle ADE over the area of triangle BDE is equals to the area of a triangle AED over area of triangle CED. So now we can say then therefore the area of triangle ADE over the area of triangle BDE is equals to the area of triangle that is AED over the area of triangle CED. And then we know that so what we know here is just that the area of triangle ADE over the area of triangle BDE, we found it as a AD over here. Here it is AD over that is BD, which is equals to now area of triangle AED over the area of triangle CED as AE over EC. So AE over EC. So now it means that we are done proving the proportionality. So here it is, we proved the proportionality. Now we are done. Anyway, that's it. That's it for this video. Thanks for watching.